Hi, Nick. How you doing?
Wrecker, good. How are you?
I'm okay. I'm okay. We got a guest today, Jin Gerlach. Hello, Jin. How you doing?
Hi guys, I'm fine. How are you?
I'm good, thank you. Look, the first question I got to ask you, what's with that name, Jin Gerlach? It's sort of like Gerlach is a very German name, and Jin is not. So what's the story there?
It's a Korean name. I come from Korea, was adopted by German parents. So that's where my German name comes from, and I kept my Korean first name.
Oh, that's awesome. So do you speak Korean?
No, not at all. I came to Germany when I was 1.5 year old. I never learned the language. So no.
You know what? You know what we call someone who's part Korean and part German?
No.
An American. So you're an American, whether you know it or not. You know.
Oh, Jesus Christ! So, but did you go to ISIS in Korea a couple of years ago?
Yeah, it was, and that was actually I think my second time there. It was really exciting to be there, but it felt like a vacation. It felt, well, ISIS was of course hard work, but it felt like being there felt like being a visitor, being on vacation.
That was one of my favorite conferences in recent years. That was really good. And like the surroundings of conference, everything was good. Look, that's not why we're here, of course, but we want to talk about your paper. You and a host of like 7 co-authors, you guys published a paper which, frankly, I've loved from the outset, which is using agent-based simulation to talk about organizational learning involving humans and AI, right? So you had a very simple idea, I thought, which is you have a look at how organizational learning works, and you relax the assumptions that it's not only humans that can learn, but also technology. So, I want to talk a little bit about this. So very simple.
Yeah, so wait, I think we need a little background though for our listeners who might.
It.
So there's the bottom line is there's James March, the towering figure in this organizational learning discourse, and he's got the world famous paper on exploration and exploitation, right? And as we all know, it's 1991 March, right? And as we all know, it's exploitation is kind of incremental innovation, execution, the little stuff. Exploration is distal, right? It's open-ended. And what you did, Jin, is kind of tried to update this with machine learning, right?
Yeah, exactly. We know that an organization's knowledge is an emergent outcome of a complex and dynamic process of interacting learners. March demonstrated this very nicely, and now you throw in machine learning systems as a new type of learning participant whose learning outcomes affect human learning and vice versa. So now you have an even more complex system that we don't understand how that works and how good or bad organizational knowledge emerges from such a system, and that's what we wanted to study.
Yeah, and we're not going to get into summarizing the paper too much, but I think one of the beautiful things about your paper is that you distinguished machine learning from IT, right? Right. And I don't know, right? IT is, it supports human learning and machine learning is somehow different, right?
So I want to, before we talk about this, I had that on my list as well, how you defined machine learning. But before this, where did this idea come from? I think that a lot of listeners want to know, like, okay, that sounds like a simple idea. Like, in a way, when you hear it now, you take the 1991 model and you bring it up 30 years later in a world where technologies can learn. It sounds obvious, doesn't it, now in hindsight? But of course, someone had to do it, right? So where's this idea coming from? We talked a little bit about ideas and where they come from and who had them and so forth in the past. Can you remember what the origin of all this was?
I can remember that very well because first of all, let me disclose that nothing of this project had existed before the call for papers came out. There was this call for papers. No, there was this call for papers, I think in June or so, and the submission deadline was in November.
Yeah, it was really tight.
Yeah, this gave us less than half a year to generate a paper from scratch, and we sat down.
Wow.
We sat down, the 8 of us.
That's amazing.
Yeah, our goal was not to get people to start papers. We were thinking all these people working on papers would send them to our special issue. That's funny that you started.
Well, that's mind-boggling, really.
I wonder how many others did that.
Well, we were working on several projects, but we thought we had to do something new, something different for this special issue. So we started with the question: where do we think really engineering, like when we think that machine learning might have the most significant impacts on organization or management theory. And so we spent a couple of weeks to really think about this, read, and we went into all kinds of different directions. And then we had a few ideas to select from, like organizational culture or leadership theory. And we chose organizational learning because we really felt that this was an idea that excited all of us. And there was this March paper which actually did simulations and that matched with our skill set. And
oh, wait a second. The March paper had the idea, right? And James March, if you look back at March and Simon's book, Organizations, back in the 50s, they basically, he didn't call it exploration exploitation. There was, local search, distal search. They talked about why organizations search in different ways and learn. So that was like the predecessor. But in that exploration exploitation paper, he basically used the simulation to illustrate the ideas he already had, right? That's not what you did. You used the agent-based modeling, a different form of simulation, to actually inquire about, right? And to get findings. How does that work? I mean, I'm not an agent-based modeling expert. How do you create something and then use it to, like, you made it up, basically? How do you take something you made up and then inquire about it, inquire about the world with this thing you made up?
Well, we looked at we got to the March paper and analyzed how is reality represented in that model, and how can we integrate machine learning into that model? So that was one of the greatest challenges in this project. At this high level of abstraction, how do we differentiate between human learners and machine learning? And that was actually one of the biggest tasks that we had to think about during the project. And
that's the beauty of the paper, certainly.
It is, absolutely. And I think from my recollection of that entire review and revision process, that was really the sort of the turning point, right? Once you got that figured out, it took a round or two until you got that modeling, I guess, done. And then the rest was relatively straightforward, I suppose. You mentioned that you looked around and you ended up with March's paper and simulation and felt it suited your skill set. Did you do a lot of agent-based modeling before that? Like, I wouldn't associate you with it as a simulation guy, to be honest.
No, I never did something like that. And we had the skill set in our team. We had people who were really, really good at writing very efficient code for the simulations. And we had Ning, who's obviously an agent-based simulation expert, who really, really helped us with setting up the model and interpreting the results, etc. I think we also, using this method was the result of us having the skill set and also not having the time to do any other type of study in that short period of time,
Yeah. That is true. So the other thing I find amazing, just real quick, is you have about 7 co-authors. I think 4 or 5 of which are PhD students, right? I mean, you got Ning Nan, you got Peter Buxmann, so like 3 professors there, but also 3 or 4 PhD students, right? Which is amazing. Talk us about them. Was it their first paper experience? Did they go off and drink whiskey for a week after you got the paper accepted? Because in one episode I said that's what I did with my first big paper. I just went partying for a week. How was it for the young guys? I looked some of them up. They are PhD students, aren't they?
They're all PhD students, and it was amazing. And we actually wanted to drink for a week, but then the pandemic.
Yeah, fair enough.
So, but it was really, really challenging to do this, but it wouldn't have been possible without any single one of us. I'm deeply convinced we wouldn't have managed to pull this off without with any one of us missing. And before this project, I never thought of this being an option, having such a big team, but it turned out to work really, really well for us. The team was very close, which helped us because we felt very comfortable to be very critical with each other's ideas. And And we use Scrum principles, which I never did on a research project before. We had these sprints and daily, weekly meetings, had a backlog, etc.
Wow, Scrum with a paper.
Yeah, I never did this before, but it was really, really fun and exciting, and it really turned out to work well for us.
So you had, tell me about these Scrum practices. Were you all in one location? So did you follow Scrum really faithfully?
Yeah, we actually did because of our backgrounds. We knew the methods, and we had all used it in some form or the other. And as we started with this project, we were all sitting in one room together daily, which changed over the course of this project, of course. But we really adhered to the principles, did the sprints. We had a Scrum Master looking that everything went right. I was the one who looked at the backlog, and this really worked well. And I'm not sure if it'll work again in the future with a different team, but for this project, it was worked really well.
So I haven't really worked a lot with 6 or 7 co-authors, right? And when I did, usually it means that there's 1 or 2 guys that sort of really take the lead and write a lot, and the others give input and stuff like this, but certainly not all 7 of them writing. And I don't think that you can't possibly have all 7 writing, right? That would be horrible. And I don't remember ever coming across any of your version thinking, oh, Jesus Christ, I got to work on the consistency. So did you have some defined roles? Like, I don't know, you're writing and this guy does the math and this guy does the stats and this one does I don't know. Did you have some of the defined roles?
Yeah, we had very complementary skills in the team. Some of us were really good at writing the code for the simulations and starting the computations. Others had very deep machine learning knowledge, which helped us in the conceptual part. Others were very good at understanding patterns that we saw in the data. So we actually had sub-teams that were specialized. Not all of us wrote, of course. And this helped us to really distribute the work and make this happen in a short period of time.
Yeah. So that's cool about the paper, but you both ignored me about my question on agent-based modeling. So I want to go back there, and you both have to, because I'm a little bit familiar with agent-based modeling, and I know it's very difficult to publish. And I know that analytical models, right, closed form, formal models, we have a tradition for doing that. And it's not agent-based modeling, right? Agent-based modeling is far more open-ended. We don't know what the outcome is, right? We're looking at the ramifications of our assumptions, essentially, but we're doing it in kind of an open-ended sort of way, right? How do you, now you Jin, with your paper, came to an editorial group with our special issue that is kind of friendly and interested in agent-based modeling. A lot of editors aren't going to be. And Recker, maybe you could talk about this. How do you publish an agent-based modeling paper? Like, how do you convince someone who's maybe not already an agent-based modeling person? And how do you convince that person anyway, even if they are familiar with agent-based modeling? What's the advantage of this technique? How do you sell it?
Well, like, I have some personal views on this. I haven't published anything on this. So I've looked at several of them, and I'm working on one of these projects. I think there's incredible advantages in this. I think it's being put in a box all the way too often. Simulation comes with this assumption that it's a weak form of evaluation. I think that's what most people think. Like, you have a hypothesis, or you have some idea, you want to prove it, or, and simulation is one way of doing so, and it's a weak way of doing so. So that puts you in a box, and that puts you in a box you don't want to be in. And I think what people don't realize is that I think the simulation is a wonderful tool for theory generating. Sort of exploration, what you guys did. You built this model, and you basically said, look, we don't know what the outcome is, so we don't want to, we don't have an hypothesis about exploration through machine learning, namely that it's going to be high, and then I'm using simulation to show that. No, you're saying, look, well, let's build this model, hit the button and see what comes out of it. And in that sense, I think it has an incredible, powerful package. Because you can obviously generate it to cover all sorts of scenarios, right? You can say, look, oh, you don't like this? That's okay. I'm going to change the parameters. And then we simulate this other scenario. And we simulate one that is more realistic and one that's really outrageously unrealistic. And I'm covering all of this. And I can tell you the bounds. I think there's lots of benefits to it, but it's not necessarily what people expect. And that's the that's the big issue, I think. Not what it can or cannot do, but rather what people associate with this and whether you can sort of deny their assumptions about it.
And I think I didn't know about having a hard time publishing agent-based modeling research. I hadn't done an agent-based modeling study before that project. I just saw that there were agent-based modeling studies out there, like the famous Kane and Alavi paper on organizational learning and others. But I thought we don't have much real-world data yet to analyze long-term effects of large-scale machine learning use in organizations. So, but if you want to talk about this and explore this, you have to use some kind of method, and that's what agent-based modeling comes in. It gives you the opportunity to look at emergent outcomes of a complex system where there's interactions between different types of agents over time, and you just cannot simply predict the outcome of such interactions.
And what you're doing is you actually said something just now in the way you were describing it is we don't have real world data yet, right? So that kind of implies that, well, if we did have real world data, then we wouldn't need agent-based modeling, right?
Well, I give you one application area, and it isn't mine, but it's by my ex-colleague Wolf Ketter in Cologne. So Wolf Ketter, Alok Gupta, and others, they do a lot of simulation for policy making. Yeah, so they, especially in the mobility and energy sector, so they're simulating what happens in Germany when we have not 10% of electric cars, but 70%. And where do we have to put all the plugs? And what do we do with all the gas stations and all these sorts of things? We don't know. And we can't just build power plugs everywhere and get rid of all the gas stations and figure it out. So the only way to get to some sort of way of knowing what a policy should look like is by simulating a range of scenarios and saying, well, that's a likely scenario, or that is not a likely scenario. But in either way, I can tell you at least you need at least, I don't know, one every square kilometer and at most 10 of them. And that's something I don't know any other way other than simulation. And if you think about how policy is being made, very often it's just based on what people think, so that's an incredibly powerful tool. It's very hard to do well, but, it's incredibly powerful, I think.
So and I would argue, even if you had data, real world complex data is probably going to be really noisy. So you would not be able to isolate the effect of, say, machine learning on learning, organizational learning very well, right? There would be a lot of confounds, a lot of noise, a lot of messiness. So what this enables you to do is really clarify outcomes based on your assumptions, right? So, I like the idea of agent-based modeling. I would like to do it one day, or be part of a project.
You need to read a couple of math books before you get there, my friend.
Oh, come on, math. I'm basically a mathematician.
You're basically a mathematician. So, Jin, I have a question. Like in your team, or you, or some of the other guys, are you going to follow up the simulation study with, let's say, I don't know, a real-world case study of some organization that uses ML and have a look at how they learn? Sort of like an empirical, evaluation of your simulated predictions? Are you going to do any of that?
Yeah, that of course that would be great to do, and I think that's an important next step. We haven't thought about a particular project or a particular case that we could study. Definitely have to think about that.
Okay. All right. So maybe one more item, right? So we touched upon this a little bit. So my recollection of the review process was that the turning point was when you guys figured out how you could conceptualize AI. Nick, you made that point about what you liked about the papers, that they distinguished AI from IT. And I guess it's fair to say when we handled all these papers, the ones that made and the ones that didn't, I think the biggest challenge for all of them was to really think about, well, what is AI? Right. And in your case, that was particularly important because it wasn't just a sentence that had to appear somewhere as a definition, right? It had to become a mathematical operationalization, like parameters that you could put into the simulation engine, right? Can you talk us a little bit through this? What did you do? How did you come up with your conceptualization such that it worked?
That was really the big challenge in our project. And you might remember the first version we sent in where we had these messy managerial decisions representing parameters of machine learning use in organizations. And when we made it to the second round, we really basically started from scratch conceptualizing machine learning, and this was a critical phase in the project, and we really took a lot of time for thinking about this despite the tight timeline. And we thought, what is machine learning? Basically, it's learning with algorithms based on data. And what are data? Data are representations of real world things. So and then it all came together because March has this representation of reality. And if you want to look at reality, there can be some kind of representation of this reality vector. There's a certain quality of the data that the representations might be more or less faithful of the actual reality. And then you use algorithms on these data to extract or to build a model, and that's where additional noise comes in. And so this very general approach to conceptualizing machine learning, I think the March model really, it all came together. The March model gave us the building blocks for actually operationalizing this idea, this very general high-level idea of machine learning. So I'm not sure, it all came together. And
so Jin, this is my suggestion for you to do next with your group, since you said you don't know what to do. I think you need to extend your existing paper. Because March, you haven't, what your paper is the first word on the topic. There's still plenty to be said, right? And I would argue that a lot of what March's paper had was that socialization over time. And although you found some ways to introduce diversity, kind of, I forget exactly how, through some sort of trigger or something, right? What they had is by adding people, and then those people get socialized over time. The temporal element of socialization into and then not searching wide, and then maybe even going back to March and Simon organizations and looking at their different reasons for why people did local search versus distal search and those sorts of things. You could simulate a lot. So I think you should kind of take that social end, continue extending March, and then send it to Recker as the SE at MISQ, and he'll
you send me more
usher
papers.
it through again.
Everyone can send me all their papers. In fact,
you're their agent-based modeling papers because you clearly love this stuff, right? So,
no, I do, but I will say this. I mean, like, if I had just published an agent-based modeling paper, I mean, I would take the same template and do it again. Absolutely. I mean, it makes so much sense, right? In terms of scaling it up. I agree. There's many questions, sort of both in that very context, sort of follow-up questions, and you could dig deeper and dig deeper and dig deeper and so forth. But yeah, it makes total sense. Also, you just learned how you can get such a work published. Definitely would do the same thing. It sounds like the most logical thing to do, following one success, to follow the same template. Why wouldn't you?
And that Kane and Alavi paper, that was in OrgSci, wasn't it?
It was, yeah.
Yeah, so send the next one to OrgSci, and they'll.
Yeah, then I don't have to handle it.
Put Jan as a reviewer.
We'll do that.
If we continue with this podcast, I think what I'll do here is I just build up conflicts of interest with everyone, and then I can just push back on all these review invitations. I'm sorry, I just know these people too well.
So do you have a conflict of interest now with Jin, now that we've talked to him and we've become his friend?
No. I mean, we've met before. We shared a beer before. I should not talk about drinking all the time. It makes me sound like
you have a problem.
Right? I have a problem. All sorts
you
of
do.
problem. Look, Jin, it was great having you on the show. Congratulations again on that paper. I really liked it from the start. We all did, in fact, and it's great. We all look forward to seeing it come out in September. And I know you just started in Passau as a professor, so good luck on that. It's probably difficult to start virtually at a new university. Would you agree?
It is. It has its advantages, but also I miss the people around me, and of course
I think we all do. Well, we hope we can, I don't know, get together at maybe at ISIS or some later conference next year
Texas.
In Texas or somewhere else, and then get to see each other again. That would be nice. All right. Thanks for being on the show.
Thanks so much for having me, and thanks again for your hard work on the special issue.